An engine coolant is a heat transfer fluid designed to remove excess heat from an internal combustion engine. It also serves to prevent freezing and, most importantly, protection from corrosion. An operating engine typically converts only 1/3 of the energy derived through the combustion of fuel into work that moves the vehicle. The other 2/3 are converted into heat, of which 1/3 goes out with the exhaust. This leaves the remaining third in the engine block, necessitating the need for a coolant to absorb this heat, transport it to the radiator and dissipate it into the environment. Through the removal of this heat by the coolant fluid, the engine is able to operate in an efficient manner. Therefore, engine coolant is a generic term used to describe fluids that remove heat from an engine, in effect cooling the engine. Not all fluids are efficient heat transfer materials when employed in the extreme setting as found in a combustion engine. Selection of the proper fluid is influenced by the environment in which the engine is used and the interaction of the fluid with the materials that comprise the engine. Some environments, such as those found in northern latitudes, may expose an engine to periods of extreme cold, requiring the fluid to remain liquid in order to function properly. In effect, the heat transfer fluid must be impervious to freezing, or expressed in other terms, it must possess anti-freezing characteristics. It is for this reason that engine coolant is sometimes referred to as antifreeze. The two main glycols that are used as engine coolants are ethylene glycol and propylene glycol. Both can be used in automotive or heavy-duty engine coolants or glycol-based heat transfer fluids, although it is generally accepted that ethylene glycol-based fluids, when used as directed, offer the greatest cost-effective performance advantage. Propylene glycol-based engine coolants or low-temperature heat transfer fluids tend to be used in locations where a low-toxicity product is required, and due to the toxicity of ethylene glycol that cannot be used. Other base fluids are coming available in the engine coolant market, such as 1,3-propanediol, otherwise known as PDO, and glycerin. However, since the majority of the global engine coolant market uses either glycols or water, we will focus on the use of these materials when discussing engine coolants and heat transfer fluids. Engine coolants perform several functions in addition to providing freeze and boil protection. Coolants must also contain additives that inhibit corrosion and scale formation in the engine's cooling system. Modern engine coolants use a mixture of glycol and water, or just deionized water with corrosion inhibitor chemicals and dyes included, completing the package.